Hello. This is the second DSA pulse. So we will start today with different problem. Find duplicate numbers. Yeah, let me share it. So yeah, yeah. For me, embedded Linux and OSP engineer with a strong experience in embedded system, Android kernel, and low-level programming. I focus on clean, efficient code and solving complex system problem. And this is the second episode in the series of 108 DSA probe pulses. So the series covers deep technical topics related to problem solving and coding. So in this episode, we will continue exploring advanced concepts and the practical solution to real world problems. And the goal is to build your understanding step by step and provide actionable sites. And I need everyone to apply the structure approach during the interview. So there's a problem with us today. Yeah, let's read the problem together. This is find a duplicate number. Okay. Given an array of integer nums containing n plus 1 integers where each integer is in range 1 n inclusive, and there is only one repeated number in nums, return this repeated number. You must solve the problem without modifying the array nums and using only constant extra space. Okay. So this is already some constraints here, and we have nums 1 3 4 to 2, so 2 here it is duplicate, so the output will be 2, and here 3 duplicate, we get 3, and here all of the number are the same, so we get it. There are some constraints here in within the range from 1 to 10 power 5, and the nums dot length n plus 1, and the nums of I range from 1 to n. All the integers in nums appear only once, except for precisely one integer which appears, and so on. Okay, so these are our constraints. Okay, and now yeah, during the interview you need to really to follow a structure approach. Okay, so first thing, you need to restate the problem or understanding the problem first. So I will starting to apply the structure approach. First thing, sorry, I will, yeah, I will starting with understanding the problem. So uh, first step, you will already understand the problem with interviewers. Okay, so yeah, let me begin by summarizing the problem to ensure full alignment on what is being asked. So first thing, you are given an array of n plus 1 integers where each integer is between from 1 to n. Okay, and yeah, okay, so first thing, yeah, this is only one, there is only one repeat number, but it could be repeat more than once. And our task here is to find the duplicate number, and the problem ask for solution in with linear runtime and the constant extra space. Okay, this is our problem today. And second thing, after you understanding and align with interviewer, you need to ask some clarifying question to gather all of the requirement. So for me, I can thinking about yeah, can the duplicate number appear more than twice? I think yes. Okay, as you see now here in the example. And another question we can say, are we allowed to modify the input array? Yeah, I think this is no. As per constraints, we cannot do that. And I have another question. Maybe is there always exactly one duplicate? I think this is appeared as yes, granted by the problem. So after that, you can, after the ask clarifying question, you can already walk through on some example, okay, to ensure more that everything is okay with you. So you can already move on some examples, like the already given example 1 3 4 to 2, so I get 2, here 3 1 3 4, and so on, I get 3, and so on. So after that, you can already now state your assumptions. So this is number 4, I will set assumptions based on the constraints, based on the requirement, and based on everything. So a very important thing here is most important, the edge cases. You need to handle the edge cases. Okay, edge cases here, as you see now here, all elements are the same, like 3 3 3 3, and duplicate is at the start or end. Okay, maybe at the 1 1 2 3 4, or 1 2 3 4 4, and so on at the beginning or the end. Maybe you have large n, like 10 bar 5. Okay, based on constraint. And yeah, maybe we have duplicate appears more than twice. Okay, like this, like already maybe you have 3 times of 3, for example, and maybe minimum size 1 1, and so on. So this is a problem. You need to already share your thoughts with the interviewers. Okay, so you can already mention it as and your intuition, or your high level design, as you like, anything you are thinking now. So here I'm thinking about the array can be seen as a linked list, where each index points to the value at that index, and the duplicate number creates a cycle just like in a linked list with a loop. And we can use Floyd's tortoise and her cycle detection algorithm to find the duplicate. We can use 2 pointers, slow and fast, to find the intersection point in the cycle, and reset 1 pointer to the start and move both at the same speed to find the entrance to the cycle. This is a duplicate. Okay, maybe you can starting with the brute force. Brute force here we can use a set to track scene number, and for each number check if it is already in set or not. If yes, return it. Time complexity here for brute force big of n, but the space still big of n, not allowed by constraints. Okay, so I will thinking about the optimized approach, as I told you in high level, or my thought. Yeah, we can initialize 2 pointer, slow and fast, move slow by 1 step, and fast by 2 steps until they meet. Okay, so then I will reset 1 pointer to start, move both by 1 step until they meet again. That is the duplicate. Okay, this is big of n time complexity and big of 1 as a space. Okay, so let's start with it, with this solution. Okay, I will start with initialize slow. I will initialize it by declare the slow and initialize it by nums of 0, and I will also create a fast pointer and initialize it by nums of 0. Okay, yeah, this is first one. So first, yeah, I can here find intersection point by looping like do while. Okay, this do I will set the slow by nums of slow. Okay, and I will set the fast with the nums of fast. Okay, if you already get the paper and pen and already track this solution, you will get and focus on solution. And okay, then this is still until while slow not equal fast, Okay, this is first one. Then I will find the entrance to cycle by the set slow with nums of 0. Okay, and then while slow not equal fast, I will do something different. Okay, so I will set slow with nums of slow. Okay, and then I will set fast with nums dot slow dot sorry fast. Okay, this is our solution. Then I will return the slow. So you can check with example. Yeah, there are a lot of alternatives, and we can already discuss the trade-offs. Yes, say we can using the binary search on value range, not and so on. And you can already trace the code, and we already discussed the complexity. This is our solution. Yeah, and then you can test our code and see if there is any bug. Yeah, it is okay with us. And now it is okay also. So the very important thing here to be have a structured approach, understanding the problem, ask, you walk through the some example and so on. I think this is that's all of my side today, and yeah, see you on the next episodes. Thank you. Bye bye.